some things that what we are doing at Respond.io and how which technology we're using and all the stuffs related to our company. And then we have 3 speakers coming in, and as well as we have a session for hiring announcements, and at the last we have a Kahoot quiz. So we are giving away some cool Docker swags, whoever gonna be in the top 3. So make sure you guys are looking for Ravi if you are in the top 3. Yeah, Docker swags. Cool. So yeah, let's welcome Zidane to share with us some updates in our Bass Corner.
Hello, how are you doing, guys? Yeah, so many things are happening nowadays. There's AI everywhere, but I'm not talking about AI today. So I'll just quickly brief what's happening, what is the new releases of some of the cool tools. Yeah, here. So, not here. Here. Not here. Okay, so who knows para Viva? Okay, so that's a good project. Actually, it has been released. So the current version is 2.0, but it's actually kind of built on the eBPF. It's kind of a project where it has a lot of instrumentation without touching any code. So if you are new to OpenTelemetry or
we should
new
put
to
it closer.
Doing metrics or migrating from
not the microphone,
all
the phone.
backends
The phone is the
all the
microphone.
project, and you need some instrumentation, this tool is where you go. So you just install it out of the box. It will give you all the instrumentation, all the gRPC code, all the HTTP code. This new version actually has a lot of more protocol, like all the HTTP2 code is any SQL query, it will be there. Any Redis, any Kafka. So this is a very cool release, but as I did mention, it's only for the projects that are new to instrumentation. So you start with this tool. So OpenTelemetry. So there is a lot of things happening in OpenTelemetry right now, but I just picked a couple of them. There is the auto instrumentation with eBPF has released. This version is the first one that moving to beta. The previous versions was alpha, so it was not ready to production. This one is not ready for production, but it's more stable. So this one is the same thing. It has auto instrumentation from your Go application. Instead of you have the tracing and the things from your tool, you just have this library to inject it, and everything will be out of the box as a tracing. Yeah, and the last thing is the collector lambda extension is a very cool extension that has been released from a week ago. And that can actually monitor or do the instrumentation from your lambda function. So you can actually have the tracing and everything that coming from your lambda function, and this collector will send it wherever you are. So it's a cool one, try it out. Yeah, so Golang just released yesterday. So we have now version 1.24. It's a major release. The last one was 1.23. This is a major release just released yesterday. It has a lot of cool features. This is the release notes. Check it out.
You check.
Yeah, so we are actually opening something new. That's for the community. As we did mention, this is some things that we want to make it unique. So we just started an SRE community. We are, this is a project. It's actually kind of donating a project to be open source under the SRE community. And that's not only for the OPSI thing. If anyone is interested to be in that instantiated or has any project that you want to be open source under SRE community, they can actually donate it and be kind of maintainer to this project. And that's actually, we have a couple of announcements. I'm not sure if we passed that or not. We're supposed to have it before. Yeah, that's. So, if you scan this QR code, it's actually something new. So, we have introduced that GitHub organization. It's all of us is honored for that project. Anybody is interested to submit a project, if you have any project for open source, or anybody is willing to be maintainer for one of the projects, it can be like submitting in this form. And yeah, we do this to make an impact for all the community around us, and this is the source of the impact. You guys are the source. And that's how we're gonna do impact across the region or across the globe. Do submit it, and yeah, as I did mention, we're gonna publish the first open source project tonight. We're gonna share it on LinkedIn as well. This is a kind of project for Go SDK wrapper. So instead of you do everything from scratch from OpenTelemetry, this package will be there for you to use just one line of code, and then you start to instrument your application. And if you do have any project like Terraform Duel that you are willing to be open and share it for folks to maintain it, as well as be a lot of people to use it under SRE community, you can do that. Terraform, Puppet, Kubernetes, anything, any automation that you do, any observability tool that you are willing to share, or some scripts. Every month we're gonna select one project, and we're gonna kind of go live, and we kind of inheriting from CNCF. What they do is actually they do have a project. Under this project, it's a maintainer, and every month they do have a meeting, go live, where is the roadmap, what you're gonna do, and so on. So we're kind of starting this for the community. Yeah, that's all from my side. Thank you guys so much.
Thanks, Zidane, for those updates. Now, let's welcome our CTO, Hassan Ahmed, to share about our Respond.io, what we are doing. Okay?
Hello everyone, I'm Hassan, I'm the CTO and co-founder of Respond.io. It's great to see so many cloud enthusiasts and developers gathered here. I hope you guys find the sessions interesting. We have an incredible team of developers and DevOps guys who have done some architected some great solutions. So I hope you guys learn a thing or two from them. Before we start with the sessions, I'm just gonna give a quick overview of Respond.io, like what we do, and also just to I'll highlight a little bit about our journey, just to inspire you guys, maybe hopefully right from the beginning. So before in 2008 years back in the day, we were called Rocket Boards. Some of you guys might know that, right? I met my co-founders in Hong Kong, where I went on a scholarship internship, and my co-founder actually came up with this idea that we could create like chatbots for customers, which would work over messaging apps. Like at that time, it was Messenger and WeChat, and that's going to be huge. So since I'm from Pakistan, I went back and started hiring the guys and trained them and formed a team of 8 people. That took like a year or two. And then, that's how we built the prototype, and we raised some funds, and that allowed us to bring our whole team to Malaysia. Since then, our product has evolved a lot, and it's become quite complicated. We rebranded to Respond.io, and after 5 years now in Malaysia, we have grown our team to like more than 50 people. I'm just talking about the engineers. And then, I mean, the rest of the team is quite big. More than 170 people, I think, in our whole company. We lose track of how many we keep hiring. So yeah, so that's the story of how we came to be. Now, what we do, what our product does basically is it's a SaaS platform that helps businesses sell better and grow their revenue by facilitating conversations with their customers, both text and voice, in a unified inbox. So that's basically our primary value. We also, so basically we have quite a few different channels that the businesses can integrate with. That includes website, some social media like Facebook, Instagram, TikTok, and now we are also adding call support. So that's a big one. Because we have only been specializing in messaging, and now calls is like a whole different category. We are the first ones to partner with WhatsApp to release voice over IP or WhatsApp. So that's gonna grow our revenue quite a bit. There's not a whole list of features, but it's the core of what we do. So we also have AI automation and human support combined in our platform. So far, do you guys have any questions? I don't want to just keep talking. Maybe you guys are curious about some aspects so far. How many of you guys are developers, like actively developing? Okay, and DevOps? Okay, nice. I'm not a lot of you guys, by the way. So the rest are just enthusiasts, you just want to learn about DevOps and stuff, right? Okay, you have a question, I think in the back. Oh, no, I'm telling you didn't have a question? Okay.
There's no door. I think the door is open.
How do we start with an idea?
You're sitting next to her.
Sorry?
Wow.
Yeah, so we went through a couple of rounds of funding. I think 3, if I remember correctly. So the first one was the seed funding, that was we were back in Pakistan, and then we also went through a Series A and pre-Series A and then Series A. So, I mean, you just start with a prototype first, right? You build with whatever you can. Back then we had a very outdated technology. We were using like Laravel. The whole architecture was monolithic, and that was the best we could do. And it took a long time to develop something because we had a very small team, 8 people, both including both developers and QA, front and back end. So that was the whole thing. They were like architecting creating infrastructure as well. So yeah, like we just create a prototype, and the business guys are my co-founders, and the person who built stuff. So yeah, that's the. Thanks for the question. Okay, so this is just some metrics. We process 200 million messages per month. That's like 5-6 million per day. Active contacts are 500,000 active contacts. 30 million plus contacts have been stored in our database. So as you can see, we operate at a very high scale, and which means we have to use the cutting edge AWS services. We use more than like around 50 services. So this is the infrastructure in numbers. The events indicate like the SQS, SNS, and event bridge events. Backend latency on average for our services is 200 milliseconds. And availability, when we really calculated, it's like 3 minutes downtime in the whole year. So it's pretty good. Our customers really like it. Deployment. So we have our own in-house model of how we develop projects and how we deploy them. We call them flights. So it's basically like a group of teams or people come together, and that's like a flight team. And then it's like not really Scrum, which we were using before, but this model really allows us to develop the features independently of each other and deploy them continuously. So it's something which has worked really well for us. So that's the metrics, how much deployments we do per week. We use BuildKite for CI/CD, by the way. So we use serverless first approach. Now I'm happy to say we have a completely distributed architecture. It's no longer monolithic. Everything's on basically everything is serverless. Okay. So far, any questions?
How stressful were the 3 minutes of downtime last year for you guys?
I mean, some issues are quite hectic for us. We use PagerDuty for incidents like that. So if hotfix comes, we have WhatsApp group too, where it's like the highest priority when we above Slack. So whether it's like nighttime or whatever, we still have to get on it and fix it. The good thing is I don't have to do it personally, so I just the guys do it. But yeah, when we have a smaller team, we were hustling quite a bit. How are we doing with the time? We have a few minutes, okay. So this is the architecture. We use Node.js. These are the core technologies. We use these different databases, CloudFormation and Terraform for infrastructure as code. These are some of the other third-party providers that we're using. This is not an exhaustive list. We use a lot of third-party. These are just the big ones. And then, this I already discussed, 100% of our computing is done on serverless. The rest is ECS, so we don't use Kubernetes. It's like ECS using Fargate or microservices basically. Then these are the databases. DynamoDB is used to store all the messages. We have like 7-8 billion messages so far that we have accumulated. So that's all served from DynamoDB, which works quite well in this regard. Then we have RDS, which is for structured data like organization, users, workspaces, and so on. There's a lot of tables there. And then Redis we use quite heavily as a caching and performance layer basically. Security, these are required. We are ISO certified by the way. We use WAF, Guard Duty, Inspector, Code Tool Security, Dependabot by GitHub, OpenVPN. So the whole entire team, when they have to access our servers, they go through OpenVPN with MFA. These are some of the networking related services. And this is a bit of an outdated overview of our entire architecture. So these are the different building blocks, the different features, roughly translate to this kind of architecture. This is a very high level overview, but basically as you can see, like we have messaging providers. They send us a webhook event. Then we have integrations, authentication. We also have an AI feature which we call Respond AI. We use OpenAI for that. We have a custom-built virus scanning solution. So all the files which are uploaded by the user goes to S3, and then we scan it ourselves using Avast antivirus. And that's like I forgot the metrics for that, but like it's a lot of files are being scanned with. And then yes, that's pretty much it. Yeah, any questions?
Yeah, earlier you said you had 3 minutes of downtime, right, last year. Is that like a full outage, or does that include partial, like degraded outages, or what?
I would say partial, you can say.
It includes the partial ones?
Yeah.
It's pretty impressive.
Yeah. The way we calculate is basically like the messages that are coming in should not be lost, so we keep like storing them. Even if the user cannot see them, if they're not available at all times, they still should be stored properly. So we should not lose messages and context. That would be the best case scenario. So some of that downtime, I think, maybe refers to that. Yeah. mean, are you asking in the sense like do you use it for training or for own models? Or? I wouldn't say we have done anything there. We don't really use that data. Like we don't really create our own models. It could be used. It's a very valuable data. It's a lot of data. So yeah, it can be used. I mean, data is king nowadays, right? So you had a question?
Technology. I think you may have how you manage your team there, how to combine all the resources to different database, different technology to one platform.
So if I understand correctly, you're saying like how do we allocate our resources? You're talking about the human resources or no? Yeah. Yeah, it's too complicated. Like how do they? Yeah.
How do we manage them?
Yeah, it's true. So some of our guys are really like experts in whatever domain, like they're developing. So like we always refer to them if there's something like for example, Howard, who's going to be speaking now, his Slack status is what? WhatsApp business. Babysitter, WhatsApp business babysitter. So his job is to do anything with the WhatsApp business basically, which is a big part of our platform. So yeah, each guy is responsible for one thing. And then when we started, that was when we didn't have a DevOps team, so our developers were in charge of architecture. And as I said, like we have quite an incredible team, like they're really good, and we pride ourselves in the guys we have. So this is going to be their first time really presenting, but in such a session. But I hope you guys can learn something from them. So feel free to ask any questions, and you can, if you want to go into some nitty-gritty, you can also ask them. Okay, that's pretty much it. Thank you.
Thanks, Hassan, for those insights and about everything what we do. So, are you guys enjoying? Okay, just tell me one answer. How's the food? It has to be good, right? Okay, thank you so much. Thank you. Okay, yeah, thanks goes to my colleagues in the Respond.io. Thank you so much. Okay, cool. So now we have the first speaker, Howard. He is one of our backend team leads. So he's going to speak on high performance scaling with API Gateway. He's going to share some best practices, how we're going to leverage this API Gateway to gain high performance scaling. So yeah, welcome Howard to this presentation.
1, 2, 3. Okay. Hello everyone. How are you today? Cool. So welcome to SRE Kuala Lumpur Respond.io. So my name is Howard, and today I will be talking about high performance scaling with API Gateway. Okay. So before we begin, I just want to let's do a quick check. Raise your hand. So if you have been in the industry less than a year. Between 2 to 5 years? More than 5 years? Cool. Those who are not raising hands, are you a student or retired? Cool. Anyway, so no matter where you are, right, it's always exciting to see there's a mix of fresh talents and experienced professionals in the field. So no matter where you are in your journey right now, I hope that this session will give you something valuable to take away. Okay. Okay, so today's agenda we will be mainly talking about what is API Gateway, how you can scale, what are the security best practices when working with API Gateway, and we will go through a small session of how you can build the architecture using API gateway. So then in the end, we will do a wrap up then. Okay, so a little bit about myself. I studied coding at 18 years old. So back in high school, my first language is Visual Basic. Everyone heard of Visual Basic before? Yes. Cool. So what was your first programming language? Everyone want to share? Python. I heard COBOL. Who's COBOL here?
Assembly.
Okay, so and then later I got myself an engineering degree in software engineering. Then I started my professional career back in 2018 as a full stack developer at a local agency. After 3 years working there, then I joined Respond.io and gradually worked my way up as a Scala developer. So what I do here is basically I maintain the platform security and stability, and work with other teams and to design scalable solution. And as what Hassan was mentioning just now, creativity and all, I'm one of the incident responders. So when the phone rings at 2 a.m., you wake up, look at the issues, solve it before more customers come complaining. Then that's how we maintain the high SLA anyway. So we'll start with our first topic today. What is the API gateway? Okay, so the first thing, right, you need to understand is why do we need an API gateway? Okay, so I mean, this is taken from AWS anyway. So API gateway is a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. Who here has used an API gateway before? Cool, there's quite a few. Who has actually been used, I mean, not just API gateway, other AWS tools? Nice. And what, I mean, not other than AWS, what do you guys use then? GCP, Azure, GCP? Cool.
Kong.
Sorry? Alibaba Cloud, I see. Nice. Okay, so right now, what we have to understand is that as our platform scale, right, we will face several key challenges. So the first thing is we will need to manage increasing traffic. How do we effectively handle a growing number of requests, and how do we secure our services? How do we protect the backend system from unauthorized access, and how can we ensure a seamless user experience, and how do we maintain the low latency and high availability? So imagine this, right? You have an e-commerce system that's handling thousands of requests per second. Some requests come from customers, some come from internal services, and some of them need to be processed asynchronously. So without a centralized solution, right, each service, or maybe just like you have only like one main server, then we need to handle its own security, routing, and load balancing, right? Over time, this can lead to complexity and lead to inconsistencies and also performance bottlenecks. So this is where API gateway will come in, and it becomes a critical component for scalability. Now, okay, so there are three types of APIs available offered by AWS API Gateway. So there's REST API, HTTP APIs, and WebSocket APIs. So you might be wondering what's the difference between REST and HTTP APIs. Actually, they are just RESTful APIs. It's just how AWS names them. I don't know why, you can ask them. Okay, so the main difference between REST and HTTP APIs is mostly about cost. HTTP API is cheaper and REST is more expensive. So most of the time, right, if you want to compensate with the features that REST API offers, we can just use it with a couple of more other HTTP AWS service-based HTTP APIs. let's start with scaling with API gateway. Okay, before still following me? So far so good? Cool. Okay. Now scaling API gateway, basically we have two key concepts here: load balancing and auto scaling. The other one is caching and the rate limiting. So why do we need load balancing then? So API gateway has a feature to distribute traffic across multiple backend services. You can also deploy your own ALB, application level load balancer, and also NLB, network load balancer, and they both work seamlessly with the auto scaling groups to handle demand spikes. And for caching and rate limiting, right, it can be done on the API gateway level or the application level with Redis. So with these strategies, right, you'll be able to scale effectively and build a highly efficient API architecture. So how do you secure your API gateway then? So there are three ways. First is the authentication and authorization. What you can do here is that you can have your deploy a Lambda authorizer in between your API gateway that helps you verify your own bearer tokens like JWT, and you can even connect OAuth 2.0 and even AWS Cognito if you are using it. Okay, now previously we talked about scaling is a part of an important factor in rate limiting. Yeah, so we just now we talked about rate limiting is also part of an important factor in the scaling, right? But it's also actually very important in securing API gateway as well. Why we say that is because rate limiting can help in prevent abuse like DDoS attack, and also finally in the private integrations you can also deploy a VPC link, and that links with the API gateway that access any of your internal resources, like for example your own RDS, DB. Those are not generally exposed to the public internet. Okay, so enough talk of theories. Okay, so we will start with like building an architecture here. So imagine that right now, like back the e-commerce system we had before, you have just one main server. Okay, it may not be ECS, anything else, DigitalOcean Droplet, and also up to you. So you have just one thing here, and all your routes is there, and you're connecting to any DB that your current system has. So what happens then if just that main server goes down, then everything's gone. That will be a problem, right? So with API gateway, right, what we can do is we can just scale up in a way that you have all these routes done in such a way that one gateway can be serving one endpoint, and then it distributes it to a Lambda, and then it will just basically connect back to your database. So what's the difference here is that you have all the routes separated. So because for example, like you have like I don't know, 11 today, a very high, I mean, if I know what 11 is, right? Okay, so maybe you will have a list of a huge search of orders coming in, but then your users and user registration maybe will come in, but not much people will be like listing a list of users. So what you can do here is like when you scale like this, right, you can ensure that your system will still remain stable with a lot of orders still processing, but at the same time other people can still browse normally. Okay, so now, and this is a simplified overview of what we are doing here. I mean, with the previous example. Now, API gateway, right, there's a feature that, sorry about this. So right now, if you have a gateway, right, deployed, then how can you bring it global and distribute it like what we were talking about just now? So one of the strategy you can use is you can have a CloudFront in front, which that you can have this and the NLB and the ALB configured there, where you can just direct the traffic to the API gateway and connect back to your own system. Okay, now we talk under this part, we have not actually talked about security yet. Okay, so let's move to okay. Now with all this part, CloudFront, API gateway, everything in order, so we have to protect our endpoint somehow. That's where the WAF will come in, and you have your resources protected inside the VPC. So that's one of the strategies that we can go with to deploy the API gateway. Any questions so far? Cool. Okay.
So I have a question.
Yes.
Do you manage VPC and security groups? Because I also learned this in uni. Then the first thing we do usually is do VPC first. We make a VPC and we distribute the systems into the VPC and then we create subnets. And then we assign security groups. That's the general process. That's what I learned. So how do you guys approach this?
I mean, it's very similar to what you're talking about. Because all the idea is that you have a VPC, is basically you need to protect your resources from the general internet, right? I mean, for public, you just want like a particular IP address or endpoint or authorized resource to access it. You're blocking API traffic. That's the idea of VPC. And in this case, right, you're only allowing, for example, just a particular IP address or security group from this API gateway to access the resources here. Other general public internet, they wouldn't be able to access or even see this. Okay, any other questions? Cool. Okay, so up until this point, right, we have talked about the API gateway, how you can scale, put them inside VPC, and you can distribute them globally with CloudFront and protect your endpoint with WAF. Now, there is still one problem here though. Imagine that your order, I mean, you have a surge of order coming in. This year you have a lot of orders. So what happens here is that if for some reason your Lambda's throttling limit is scaled to a point where it's already at the maximum, then you started losing orders, the data are lost. How can we prevent this? I heard somebody say queue. So actually, one of the solutions we can go with is to put a queue in front of the Lambda. So the idea is that, right, your data, right, will be stored in the queue in a way that you can control your Lambda in a manner that it won't overload your system, and you still have a way to process the messages or the records in some way. Okay, so in the next topic, we will be talking about the SQS more in detail. So that for my side, it concludes the API gateway. So Q&A session. Anybody have any questions?
So, given you have a set of API gateways and all that, what kind of do you use any framework or tool to manage your stack? Like, do you use API? Do you use SS?
We basically just deploy the CloudFormation stack. Yeah.
So, raw
I mean, we start from a template. We don't like write from scratch, and because obviously we have our own internal VPC groups and everything. Start from the template, but in general we deploy from CloudFormation. Yes.
Yeah, so you're using CloudFormation to manage your API gateway resources, the integrations, right? So how do you manage it in a scalable way whereby you can distribute the, like, for example, if I as a developer want to make a change, how do you empower me to do it? Like, is it a centralized like location where the CloudFormation is just in one place, then I have to make a change there, or is it like per microservice that we can control it individually?
In simple words, we have staging environment and production environment. So obviously, whatever you are testing, go to development first, staging environment, and once it's tested thoroughly, then only be rolled to production. Does that answer your question?
Not quite. I'm asking about if I want to make a change to the stack, right? Maybe because we manage it using Terraform, so maybe I'm not familiar with CloudFormation, but these particular resources point to a particular service, right, or Lambda, right? And that Lambda belongs to a certain team. So what if I want to change just that route? is it separated by, is the stack separated by service, or like how does it work?
It actually depends on how, I don't know, maybe a feature it was initially designed, the whole template contains everything. Maybe if that's the case, then whoever changes the template, we will really have a meeting and sit down and discuss about it, what are we changing. But anyhow, no matter how the template it is, right, usually what we do here is that first thing we always do, we go to staging first. Making sure that nothing breaks, or even after we make a template change, right, the first thing we probably do is just run a linting on a template. At least ensure there's no typo errors and everything else, then we move to the next one.
Okay, yeah, thanks.
Hi, great talk. Question is, if the business requires a global presence, like multiple regions, how does Respond.io approach the problem? How does API Gateway support global load balancing for different VPCs? Yeah, sorry, go ahead.
So for now, okay, regarding your question, actually we do have a front in place where a platform will be responsible on the global level, and it just basically redirects to our service in a specific region. We don't, I think for now we don't actually do it in such a way that it's deployed in every region.
Right.
I was taking pictures.
So there's only one API gateway for that one region.
This is just a very simple example. Obviously, the real one it was much more complicated.
Thank you very much.
Yeah, so in such a secure environment, how do you get around testing that actual environment, right? Because you must have CI/CD pipelines and everything else that's sort of actually testing not only the security, but also whether or not the application crashes in the first place before you develop something for it, right? So how would your sort of testing framework work around something that's so secure and only allowing certain IP addresses? And do you have a local sort of environment that's built up in Docker or something like that? Or do you use any sort of applications that would be good for this?
That's a good question, by the way. We do have like a pipeline, which one of the topics we will talk about it as well. Okay, but in general, we do have a unit test and everything to ensure at least your local environment would work first. Then again, passing through the CI/CD, we just deploy the staging first, make sure everything is okay, then only we will gradually roll out the production.
750.
Do the yeah, I need to wait.
You can wave to get his attention.
This is just sort of specific to the example you gave. Given that the solution to process more requests was with a queue, would that mean you, and in that example it was processed for the, does that mean that you're accepting a higher latency for a somewhat critical function?
Not really. So imagine this thing, obviously this is a simpler example. So what we do here is, let's say you have an API gateway, then coming to this point, then we just split it in a way that these all functions, they do very, very small stuff that is like, for example, checking the headers and everything, validating, and then it passes the queue that this particular function only is the one that's doing all the heavy lifting stuff, like reading DB, writing to DB, or even communicating with other third-party providers. And that's how we do it. We don't do it in such a way that everything crumbles together in one particular function. Actually, in the end of the day, it depends on your business requirements. What kind of data is so important or important enough that you cannot afford to lose it. So in our scenario, it's basically messages, right? Customer messages come in, webhooks coming in, we have to store it somehow. Even if there's a problem right away, we cannot process it right now, they still needs to be stored and be processed later. Any other questions?
Okay, that architecture actually is serving 200 million per month, right? So how you manage this scalability? I'm just curious. You use Lambda everywhere, but how do you scale Lambda? And the other thing is, do you do any kind of load test to see like, okay, we have a hypothesis that the 200 million will be 300. How are you gonna do load test in that architecture? And then the last thing is, observability, like kind of serverless is hard to do the observability, right? This is based on my experience. I don't know now.
Okay, that's a good question, sir. I mean, obviously, a lot of stuff here is actually not covered. I mean, the reason why I put this thing is basically just because I'm talking about API gateway. So obviously, in our case, right, I mean, we have monitoring system in place, we have arms in place telling us that something is wrong, and also we have some auto-scaling rules. Like if it's certain threshold, it just auto spins up more instances, or even deploy. We not just API gateway, we also use a couple of ECS instances as well. So the alarms will help us determine that something is wrong. We should be scaling up more instances and then spin down if the traffic goes down. That's the general idea.
Yeah, so it's okay, but like the scalability always hard to scale on the CPU, depends on the CPU and the memory only. So there is some kind of other things, maybe it's hidden somewhere, but that's the kind of the sample version that you have. But behind the scene, you have many other things, right?
Yes, you have a question?
What's the high availability solution for your database per se? Because if the database in that
diagram is to not exist or the route can't resolve, how are you able to still make the right query, for example?
You're talking about like reading the database and writing and...
You're doing a write to the database, right, in the diagram. So in that instance, if that resource is occupied or you cannot make a write for some reason, is there a high availability solution in place to ensure that what's your database high availability solution? That's basically the question.
Okay. I mean, again, simplified example. We are actually using multiple AWS managed services that Hassan had went through just now. We have DynamoDB, RDS, all this kind of stuff. In general, we would just rely on it where AWS internally manages all this kind of stuff.
Hi there, good session. I have two questions. So the first one is during the design phase of your whole application, why did you choose to go for serverless? And why is it good for your use case? Yeah? And then second, what are your thoughts because you're using AWS on vendor locking?
Sorry, can you repeat your first question?
First question, why did you go for serverless? Why is it good for your implementation? And then second question is, how do you go against vendor locking because you're using fully AWS, right? Thank you.
Okay, first question, I mean, why do we go for serverless is, okay, depends on the use case. In our scenario, right, I mean, going serverless is, from our point of view, is easier to manage. We don't, again, taking API gateway, for example, one of the use cases we can do here is, for example, you want to listen to webhook events. Now, these webhook events, they can scale, I mean, they can have a surge of events coming in at any given point of time. You wouldn't know how big your instance would need to be listening to this traffic. That's why we opt for fully serverless in such a way that even if there's a traffic spike coming in, we would be able to still handle those traffics. Now, for the next question regarding the vendor locking, honestly speaking, I believe there is nothing much we can do about it. Any other questions? Good then. Okay, then that will be all then. Thank you very much.
Thank you, Howard, for this nice session with API Gateway and all the insights that you have shared with us. So now we have a session we call hiring announcements.
Okay, it's time for time for that. Like anybody has kind of any talk, anything that you want to share with the community. Want to share something? Any interesting thing that happened? No? Go 1.24 if you need. Already I noticed that, but you can come. There are some features that you like.
Golang 1.24 is out. I guess YTL Digital Bank is hiring, so please come. It's a good opportunity, right?
Yes,
Sorry.
I want to talk about Go.
Golang, yes, the two chain. You don't have to pass in like the tools in there. You can just pass into the Go mod and you just run the command Go tools, then you fetch all your tools. Nice.
Anything else that's interesting?
A few library changes, I think. Yeah, the standard library. Those ones are quite interesting for me.
Yes, thank you so much for sharing. Hey, anything else that you guys want to share? Anything else interesting you guys want to share?
I want to share something about Docker, but we have a Docker captain here, so I hope I'm not. I read an article recently about using Docker Bake. So it's like a build tool for using Docker. So essentially, if you run Docker build before, usually you have this dash t blah blah blah, and then a lot of command, right? And then usually before this, you will use Docker Compose for it. So essentially, there's a new tool that just got GA, generally available. What was it last week or something? Quite new, quite recent. So essentially, it helps you build easier, and then you just when you build, you just use always the same command, so it's always repeatable and everything. And then it also supports one of the things that the previous Docker Compose doesn't support is the multi-platform builds. So if you're using it to build multi-platform like for ARM and also for AMD 64, so you can do it using Docker Bake. I've been using it in my recent project. I feel like it's really good. And one thing I read an article about it also, if you have a mono repo, you probably should look at it, because somehow this Docker Bake feature, they got like a parallelization during the build, so it will make your builds faster in terms of building multiple container images at once. So yeah, do check it out. Yeah.
Do share do share some blogs in the WhatsApp group, so it benefits other people also. Cool. So moving forward, let's move to So the SRE community group that we have created. How many of you guys are on WhatsApp group community? 1, 2. My God, 2 only. So we have a WhatsApp group for the community. So we actually post there the announcement, anything is new. Maybe you guys want to contribute, that if you found something interesting you want to share with us, just share it there. And all the news will be there. So it's for all of you to write something there. Cool, so who is hiring? India, one is hiring.
I'm from YTL Digital Bank. It's now called Right Bank. I'm a DevOps engineer there. We are finding a lead engineer to spearhead our DevOps and like reliability, SREs, whatnot. Yes. You can talk to my HR.
Thank you so much for sharing. You can also, we have in the WhatsApp group, the career group, so you can just put it there so people will reach out to you. Anyone else, guys? Okay, I guess that's all. We're gonna move to
Hello, Michael L. here again from Moneyline. I've started hiring again, so for senior and junior SRE, our stack is AWS, Terraform, Argo CD, Kubernetes, a bit of Go. So yeah, come talk to me.
Thank you so much for sharing. Moneyline is always hiring. So we're gonna do actually the SRE meetup on Moneyline on April. So we are looking for that. You're gonna speak? Yes, try to do it. Okay, Thank you so much, and we're moving to the next session.
Okay, so for the next session, Imad will be speaking about multi-tenant SaaS architecture with SQS. He is one of the backend engineers, and he's a great guy to discuss about this queue and all this stuff. So yeah, let's welcome Imad to give the speech on SQS.
Hello everyone, and good evening, and hope you are enjoying tonight. And thank you, Robert, for a great gateway session and the cool Q&A. My name is Miribal Ahmed. I am a software engineer with around 8 years of experience, and I like building scalable and cloud-based applications. And over the past year at Respond.io, I have seen this firsthand, the impact of building efficient solutions that scale with the user needs. And today we are going to look at how you can use Amazon SQS in multi-tenant SaaS architectures. So first of all, what the hell is multi-tenant SaaS? Anybody have any guess? Anyone? Feel free. Okay, so multi-tenant is basically when we have one solution, one software, and it's being used by multiple companies, multiple users, or multiple tenants. In short, we only deploy one infrastructure that is being used by multiple users instead of deploying one solution, one infrastructure per customer, right? And when there is a big scale, let's say when the applications scale at a very large scale, the messaging between the users or tenants and the services, it becomes very critical. So we cannot lose messages, we cannot lose orders and all these things. That's where the Amazon SQS comes in. So let's have a look at a few SaaS examples. For example, Google Workspace. There is same platform but multiple applications like Google Drive, Gmail, Google Meet, or whatever, right? But the users are same, and their stuff is private files, private emails, right? For example, Shopify, millions of online stores are working on shared infrastructure, but the data is separate and private to each of them, right? And last but not the least, Respond.io, where we are sitting right now, we have thousands of customers who manage their business messaging through our platform, but of course the chats and the conversations are private to each of the user. Not the user, each of the organization, like our customers, right? Any other example that you guys can think of? Anyone? No? No? Slack? Okay, yeah, nice. Anything else? Grab? Maybe, yes. Okay. What is SQS? Okay. So SQS is simple queue service from Amazon, where there can be one or multiple producers that produce some kind of message which is being saved in the queue until it's picked up by a consumer. The consumer could be any other service from Amazon. Consumer reads the message, processes it, and deletes it from the queue. If the consumer fails to process the message, it gets retried. There is a few other things that we can go about there. What are the benefits of using SQS over traditional architecture? So traditional architecture, something similar to what Howard was showing initially, where you have one API talking directly to Lambda, talking to a DB, right? So he already told what are the problems that we could face if there is high traffic, and things could go down, we could lose messages, and all those things, right? So one of the benefit is decoupling. So what SQS provides is it helps you decouple your services from each other, right? So let's take an example. So let's say an e-commerce platform. We have a user, then we have some web or mobile application that talks to some backend, right? And let's say a user posts an order for some products through the apps, and it talks to some backend, and the backend is responsible of doing everything, right? processing the payment, updating the inventory, sending emails that order is coming or whatever, and generating the shipping labels and updating to, let's say, the courier company that we should deliver this order. So now, overall, it looks okay. It's a valid architecture. But let's say what happens if we have like millions of orders every day, right? Or let's say, since we're talking about multi-tenant solutions, right? Let's say this was Shopify, right? So on Shopify, we have millions of orders every day. How does this affect them, right? Anybody, any guess what could go wrong? Anything? Noisy neighbors, true. But that happens in SQS. We haven't added SQS yet. So, of course, since this is only one backend, right? If there is a lot of traffic, it can go down. Then the others will not be able to process the orders, right? So let's see how we can solve that using SQS. Let's say we have the same backend, but instead of everything is being done on the same backend server, we have, let's say, 3 different queues. One is managing the payments, one is managing the inventory update, one is, let's say, managing the shipping labels, right? So what happens is, as soon as the order comes in from the front end or mobile app, the backend acknowledges, okay, I have received the message, and updates the user that your order is being processed, and immediately puts messages on these 3 queues. And from these queues, the Lambda picks up the message and processes the payment. The second Lambda picks up the message and updates the inventory in the database. And the third one picks up and generates the shipping labels and send to printing or some other things, right? Now, this is one of the solutions that how we can improve the previous architecture. But do you guys see any problem with this? Anybody? Exactly, because everything is parallelly happening. What if the payment fails? What if the card gets declined, right? In such a way, we would have wasted some resources, right? We would have wasted the update inventory and trigger shipping Lambda and the queue resource, right? So another way to solve this would be doing sequentially on the order. So let's say we got the order from the order service, we send it directly to the payment queue, which gets picked up by the payment Lambda. It charges the card. If the card gets charged, if it gets charged successfully, we put it to the inventory queue, which picks up by the inventory update Lambda, which updates in the database that these things are being sold out, creates the order or whatever, then puts it to the shipping queue, which eventually gets picked up by the shipping Lambda, which can generate the shipping labels, update to the service provider, whatever, right? And does anyone have any questions so far? Okay, so do you guys have any suggestion how we can further improve this and make it much a bit more faster? I mean, we of course we have to configure everything, but this is just an overall example of how generally we can architect. Yeah, of course. This is just a success scenario when the payment is actually processed. Then we only do this. Of course, if the payment fails, we could be sending to some other queue which updates the UI that your payment is failed. You need to do something, or sends an email to the user. We can do a lot of other things. But this is a general example, right? For example, what we can update here to make it even further improvised is once the payment is approved, right? Instead of doing sequentially the next 2 things, or this could have like 10 other steps in between, right? For example, we talked about sending the emails. We talked about updating the third-party shipping companies. We could do everything in parallelly, similar to what we did before. So from after the process payment, we could have parallel calls to 3 different queues, which gets picked up by 3 different members, ensuring scalability and high speed and performance, right? So from this example, we can see that using SQS, we provide high security and availability. Let's say if a payment processor has a problem, a code problem, or third-party services down, so we still have the messages in the queue, nothing will get lost. Right? And let's say we have a surge on the payment processor lambda, but that would not affect us on the other services, other lambdas, or other consumers, other queues. Right? Let's say we have a surge of orders coming in. Right? Since everything is queue-based, we would not have that issue that we faced in the first architecture. Nothing will go down because we are instantly putting into the queues, and Lambda is picking one by one from the queue and processing it, right? So this, again, we already talked about the decoupling and scalability. Of course, when we have such a serverless decoupled environment, it's scalable. Of course, if you have a lot of traffic coming in, this should be easily handle all of this, right? And it's Amazon SQS is reliable because Amazon promises that you will receive at least once this message from the queue, right? And then it's very flexible. You can, because as I discussed, we have producers and consumers. From both sides of the queue, you could have any AWS service attached. You could be receiving from API Gateway, you could be receiving from ECS, you could be receiving from SNS, and then on the consumer side as well, you are reading from queue to the Lambda or SNS or so on and so forth.
Damn, there's more to come.
Because of all of this, and the last thing that we just discussed, there is a problem that one of our colleagues said, noisy neighbor problem. So let's say even if it's very scalable, right? What happens if one of the companies that are using our system has a surge of messages compared to others? Right? Let's say one of our clients, they are a very big online retailer, right? And they have millions of orders coming in every day. But some of our other clients, they are maybe hundreds or tens of orders each day. So what happens in this scenario? If now I'm talking about on a very small scale of number, like minutes or seconds, when there is a lot of messages coming in. So what happens if there is a lot of messages for one tenant? It causes this noisy neighbor because one, for example, in the batch queue, if you see here, the tenant one tenant could be causing a throttle on a queue by sending a lot of messages. This will cause issue for other tenants that their messages get delayed. Right? This is a general problem that we face with the SQS models. So we have a few models on how we can architect multi-tenant using SQS. The first is silo model, where every tenant has their own queues, their own resources. So of course not causing the noisy neighbor problem. And
topic 3, right?
Then we have pool model, where everything is shared, all the queues are shared between all the tenants, which was causing this problem. And then there is a hybrid model, risk model, where some of the things are sharing some queues, and some of the tenants are making their own resources. Right? So let's talk about silo model. We have this example from AWS. Let's say we have Amazon API Gateway, and we have Lambda that loads the inventory, and then we have the update inventory queue for each tenant individually. Tenant A has its own queue, tenant B has its own queue. So from the first API call, the Lambda will be sending to each queue. Why we have a Lambda in between is because it's going to intelligently see which tenant it is, and then send to accordingly that other queue, right? So let's take an example of a customer support system. For example, we have a customer support system which is being used by hospitals, banks, maybe some big online stores, right? And companies like banks, they require a lot of data isolation, for compliance and all these things. So if we use a silo model for these kind of customers, we will be using the same system but separate queues for each of the tenant for all of these things, right? This will ensure the data isolation and of course the compliance. But this comes with of course a trade-off of a very heavy cost, because we are creating a lot of queues, a lot of lambdas for each of tenant, right? Then we have the pool model. Just now we discussed the same thing, but on the right side, instead of having one queue for each tenant, we will only have one queue, right, that process everything. So again, let's have a look at an example, ticketing system, right? Maybe we have a ticketing system that gets used by small e-commerce, tech startups, real estate agents, and everybody is sharing a single queue. Of course, it's efficient, but it requires you have to do tenant identification. What does I mean by tenant identification is, whenever you are processing a message, right, you need to know which customer it is, which organization it is, right? So you'll have to query the DB, or you will have to find out if it's active or not, should be still processing, a lot of these things, right? And of course, since it's pooled, everything is pooled, everything is shared. If we have an auxiliary problem, this risk condition. Then we have a bridge model where we utilize both of these models, where we use one queue. For example, in this example, we have a demand forecast producer, which is putting into one queue for each of the tenant, right, which gets picked up by two consumers each for each tenant, right? But in the same system, we have a order create producer, which is putting into just two queues, which are shared by everybody, right? So it's a mix and match of both, right? What does this provide? It provides you the ability to get best of both sides. If you have something of importance that needs for each tenant needs processing on priority basis, you use the silo model for that part. And if it's something similar, not of very importance, for example, if you are sending scheduled emails, right, and that is scheduling emails after 7 days or something like that, you could be using the pool model, shared queues, and everybody is using the same queue. Let's say you have, for example, payment processing or order processing. You could have one queue per tenant. And same ticketing example, let's say everything is same, but now we have a government agency comes in and they are also using the same system. Now they might require data isolation for compliance and or maybe for volume reasons. Then what we do is we create separate queues for specific tenants. This is in another case where we create queues for the whole system instead of the hybrid model where I just discussed. You use queues for specific things. You could also do the whole thing for specific tenant and the whole thing for some shared tenants, right? Now what extra things that we will have to do is intelligent routing, that we'll have to see which tenant it is and see if we need to send it to a shared queue or to the common queue, right? We could also have pricing-based pricing-based models. For example, we have a company which is providing 3 different plans, right? And basic plan, premium plan, and enterprise plan. So for basic plan, of course, because it might be the cheapest, or they might have free trial or whatever, they will have shared queues between all of their tenants which are on this plan, right? This might cause congestion, of course, because they might have a lot of people or a lot of customers using this plan because it's of course cheaper, and they also, as I said, might have, let's say, free trial. This might cause degraded performance, right? Then let's say they have another premium plan. What you could do is you could have shared queues, but just for the premium plan only, which is separate from basic plan or enterprise plan. Nobody else is using the premium plan. Of course, this is still pooled, but this might be a bit better than basic plan because since the premium plan might be a bit expensive, there might be less customers on that plan. And then we might have an enterprise plan where we have separate queues for each of the tenant, each of the customer. That means maximum isolation and best performance. Now all of this is hypothetical. We could have mix and match of everything. It depends on the business needs. We would be creating the best architecture. Now how do we choose the right queuing model if we are given a choice, right? Let's have a look at this table. So if we need security and compliance, we could be using silo model. but it would not be very cost effective, and of course resource usage is not very optimized. Right, we would be creating a lot of queues and a lot of lambdas and a lot of other services for each tenant, but depending on the traffic, not all of them might be using it fully. Right? Then when we have a pool model, of course everything is shared. There is no security and compliance involved here. But the cost-wise, it would be of course very effective, and resource usage is very optimized here because we are using all the infrastructure at its best. Then for the bridge model, of course, the security and compliance is somewhat balanced, right? Because you could, if you request on, let's say you're processing payment related stuff, you could be using the silent model part for that to use the compliance part of it. And then for the rest of the thing, you could be using, pool model to get the cost effectiveness and the resource usage. And there is there is a lot of others, but for the sake of time shortage and keeping it short, we have a few best practices that we can use. If you're using a pool or shared queues in the hybrid model, we should always be using message tagging depending on the tenant, right? And then we could use something called dead letter queue. What is dead letter queue is if a consumer picks up something and something goes wrong, the processing fails, or we could put it in another queue called dead letter queue. Now Amazon provides this service out of the box. You just have to configure it. Then of course we have to auto scale consumers depending on how much messages we have in the queue. What do I mean by that? Let's say if we have the consumer is an ECS worker, right? We could have Lambda, we could have SMS, we could have ECS worker. Let's say that we have an ECS with some specific CPU which is picking up from the queue and processing the messages, right? But let's say we have a surge of messages in the queue. There's a lot of messages come in the queue. Then we could, somebody asked before, how do you preemptively scale? So we could be keeping an eye on the number of messages in the queue. We could spin up more ECS to effectively manage. And once the number of messages keep going down, we scale down the message. And then of course we need to fully utilize the IAM policies and encryption from AWS. So a quick recap, we talked about the SPS models, silo model, pool model, and hybrid. Then the trade-offs, if you want a cost-effective solution, go for pool. If you want compliance, go for silo, right? And some of the best practices. And what do I recommend is if you are working on doing a multi-tenant SaaS solution, you just start with simple steps, right? And as monitor and understand business requirements and increase or decrease your resources or keep on improving your architecture based on that. And thank you so much for that. And you can connect with me on LinkedIn. I will be posting this and some other resources to read and some other code samples on my LinkedIn. And any questions now?
Have you ever had to go beyond the 1,000 lambda concurrency limit for each account in one region? And have you also had to manage, let's say you have one big tenant that you want to reserve concurrent lambda so that they will be having the priority over other tenants? Do you do any of those?
At Respond.io, we did not have a specific problem of managing, giving one tenant a priority over others. We don't have that problem. And of course, we have scalability issues every now and then. We try to manage out, some best way possible out of it. It depends on situation to situation and messages to messages, which process it is. We always find out a solution, of course. For example, the message coming in, we have a very high number of messages coming in, and for that we use SQS workers to, so that we can easily scale instead of going to them. So there can be a lot of solutions to that.
Question is, so mainly used Kafka before, and then essentially like the way I see SQS is kind of a simplified version of that. You have the queuing system, right? And then I think one of the problems I see using this message or event-based or message-driven kind of thing approach where you have, how do you handle different versions of your messages? It's like, for example, your consumers know this kind of version, but then suddenly a producer introduces new properties or something in your messaging, right? And then how do you make sure that your consumer can handle that kind of thing? Because I know in Kafka they have something like schema registry, those things that helps with those kind of problems. So yeah.
Well, it depends on situation to situation. It differs. For example, of course I can't give exact example, but the way we do is, of course, we have validation of the messages. When we pass messages through one consumer to another, we do the validation for that. And if one consumer requires some specific set of properties on the message, we of course have validations for that. Then if it's not there, we do some kind of fail scenario for that. But we definitely have situations where one message gets updated by one consumer, and when it goes to another, it requires some other properties. We definitely have this.
Actually, I also have another question based on your example just now. You mentioned, for example, the enterprise part where we have like a per tenant queue, right? So because this involves infrastructure per tenant, so I'm assuming, for example, normal SaaS based, you can just user can click and then choose a new plan and then it will act effective immediately. But in that case, because we have to provision new infrastructure, that will cause delays, right? That means that you probably need to wait a few days, or do you do like some kind of automation for that?
No. Of course, if you are doing something like this, of course, we don't need to take a few days.
Yeah.
We will of course have some kind of automation that handles all of this. On my LinkedIn, I will share a code example which is open source and being managed by AWS employees, which has all of this built in. You can take the code and learn how they do. And of course, when you create a tenant, you can provide the settings to any silo or no. Depending on that, they of course create everything, deploy all the infrastructure required, and then update it back. So of course, it's also like an asynchronous process. A few examples of this could be where you create an account and you usually get a subdomain, right? So what happens is you keep waiting for some time, or it says you that we are processing, come back later, and after maybe 5-10 minutes you get an email, okay, your workspace is set up, you can come in and start using it. Most of the time you usually have some sort of automation, if of course if it's tied to a plan. Some companies, some softwares, they might not have this, and if they have usually if they have a software which is very niche based, which requires a lot of things, they might have this manually done, but of course.
Thank you.
Here. No. Not me. No, me. I was
asking for the mic for you.
Oh, yeah. So for SQS, the order is not guaranteed, so at Respond.io, since you guys have message, I presume your message order matters, and you might even have like duplicate. How do you guys handle that, and also cases when the message is bad and you get a poison pill and go to your DLQ? How do you reprocess it correctly in the correct order?
Yeah, of course. So one of the things with SQS normal queues is the messages are not deleted in the same order it gets in. You might not get back in the same order. Now there is a few other solutions to counter that. We have FIFO queue, first in first out queues as well, that are also provided by AWS. You can use that to counter this problem. And specifically in our system, you might have timestamps attached to your messages that you would look at and display your messages accordingly.
Okay, any questions? Any more questions? Okay, cool. Thank you. Thank you, Mark, for this page about the queue and all the stuff. So
So just sharing one thing, how many of you guys have used CloudFormation? Okay, Terraform? I love it. Okay. So just want to share one update. Have you guys, the guys who used CloudFormation, have you guys heard about stack refactoring? Okay, it's a new feature that AWS have introduced 2 days ago. So suppose you think about one situation that you have a stack of resources. Now you need to shift or move these resources from those stack to another stack. How you guys do it? There is yeah, I'm asking you. Have you done something like this before? Okay, yeah. So there is a policy, they call it retention policy. So you add a deletion and retention policy in the source stack, so that if you remove the resources, the resource will be there, it will not be deleted, right? And then you create a new stack and import the resources into it. So it requires few steps, and in production it's a bit risky. There's a chance of deleting your resources if you don't handle it. So what actually this stack refactoring, this feature actually provides is, you have a source stack, you have a destination stack. So you create a JSON file, you do a mapping, a logical resource ID, you give the resources a logical ID, and you do the mapping, the source and destination, and then you execute it. So there is a CLI, is for stack refactoring. When you execute it, it will map your resources or move your resources from the previous one to the new one. So it's very efficient, and they automated this thing. Okay, that's a small update from my end, because I have faced this issue few days ago, and I had to do some manual stuff. Yeah, so then after a few days they have introduced this thing. Okay, cool. So few other questions from my side. How many of you have used GitHub Actions? Oh, okay. How many of you have used Circle CI? Okay. How many of you have used AWS Code Deploy or Code Pipeline? Okay. Now, how many of you have used Buildkite?
Bit what?
We have used Buildkite. You too, right? Okay. Seems like just only two besides Respond guys. Okay. So yeah. Let's welcome Hasita to actually talk about the Buildkite that we are using in Respond.io. Yeah. Okay. Here's to the mic to Hasita. Share us and give us some insights to use Buildkite.
To raise this.
We have a demo session after that. So yeah.
Yes, that's a smooth transition. Smooth transition, right?
So you want to movies here, bro? They have movies. You can watch movie.
Yes.
Tonight. They do have Apple TV.
Airplay code 1610.
There's Severance. Severance is part 2 has released, so you can watch.
Sure, we should make some time, no? After work.
Yeah. Okay.
Sometime. Can you take a picture of this one? Yes, he used to.
Hi everyone. I'm Hasita Gamake. I'm working as a senior cloud engineer in Respond.io. This is my third year in Respond.io. I totally have.
I might just take later of him also for our SRE.
Yeah. This is not a kind of promotion for the Buildkite because this is a kind of a tool we are using lately, because this has good advantage and it makes our lives very easy because of the complexity of I'll explain one step by step of why we use Buildkite and why we use build kite for CD part. Okay, let's start build kite. Yes, this is a kind of a tool. People not heavily used in this region. It's used in US and European region, but when we compare with Asia Pacific region, this is not a much popular tool. But yeah, let's go into this one. Actually, this is a CI/CD tool. This is a kind of a SaaS-based product. This has a lot of features we can use for to make our system more compliant and more secure. So in this case, this has a kind of flexible CI/CD architecture. So deployment is we can maintain
the whole exercise running on
flow
this.
and the security mode. That is the kind of one of important thing we use. As an example, some of CI/CD tools, so we need to use their agents and we need to push our code to their end. So in this case, every angle, most of the cases we can manage by ourselves. So this is very helpful for managing a kind of a secure environment. This is the one of reason why we use build kite. Okay. Before we go into the next slide, you can see these are the kind of main companies using the build kite. So this has a good customer base. So I think this is a kind of a good tool to have a look when we compare with other tools. Because most of the people these days use GitHub Actions, GitLab, CI/CD, and Jenkins. Jenkins is a kind of most popular one. So, but this is a kind of a easy tool. So I think we can go with the next. Yeah. These are the kind of main key areas to be built, right? But this is when we compare with the current trends of the CI/CD tools, these are the kind of a common these days. I can't say this is a kind of a complete deviation from the existing tools, but I'll explain one by one why this is more important. When we think about self-hosted agents, we have a really good ecosystem. We can easily host a self-hosted agent in our bare metal hardware. Some of containers wise also. In my demonstration, I am going to showcase how we can run the agent and how we can make the custom agent and run it in the Docker, and we can do the deployment part also. The infrastructure flexibility, we can use any type of environment. It can be the cloud, it can be on premises, we can use anywhere. And this is a kind of has a correlation with the infrastructure flexibility and scalability. And this is the one of my favorite thing, the advanced pipeline management. As an example, I'll give an example. Let's think about we have a pipeline. This pipeline, normally all the pipelines has a kind of static configuration. But in this case, we can, when we execute the current one of step, we can inject the next step based on the current state. As an example, let's take some example with CloudFormation. Let's think about our CloudFormation template is updated. So based on the template, okay, if there is any changes, we can do the change set. If there is a change set, okay, then we can add another step. Okay, we can show the change set values, then we can ask, do we need to continue or not? Based on the dynamic manner, we can inject and we can extend our pipeline on the fly. That is a kind of a good feature in the build kite. I see when we compare with other GitHub Action and these things, this is kind of a disadvantage what I feel, because when we handle the more microservices manner, so this is a kind of good advantage. I think Circle CI has this feature, but I do not use that one. Based on their documentation, they have this feature, but in the build kite, we are heavily use this one. So when we go with another one, the ecosystem. As an example, we are mainly using AWS as our cloud infrastructure. So when we think about how we can host our agents, they have already predefined template and the CloudFormation template, so we can easily host fully scalable agent system. As an example, when we think about the GitHub Action self-hosted, normally when we add a GitHub Action in agent, so we need to manage by ourselves. But when we think about build type has already predefined, fully tested stack. As an example, when we add in more steps to execute, it's automatically scale up, scale down, everything handled by us. That is a really good managed ecosystem. So yeah, I think we can go to the next one. Yeah, this is the behind the scene part of the build type. This I told you this is a kind of a SaaS product. This is the SaaS part in their ring. This is the part in our side. As an example, this SaaS part, they are admin console, and they have a GraphQL API, REST API, and webhook and everything. So we can use this part, and the rest of the code related stuff, secret management, environment variable management, everything we can handle inside our infrastructure. It means we don't need to push our code into any of third-party service. All the things we can resize inside our infrastructure. It can be on premises, it can be our cloud VPC, so any place. So this is the kind of a recommended way to handling this part of security and these things. They always promote, don't push any kind of a security or configuration related to your code into the build type level. So they always promote all the security and your code and everything you need to put it inside your infrastructure. That is their recommendation. Yeah, these are the main key benefits. I have already discussed some of the areas, the scalability and the performance. As an example, if we need to build some mobile application related to the, let's think about, we have a React Native application. We need to build React Native in the Apple if we have a kind of a set of devices, Mac minis, we can easily set up this build type and we can run these agents on top of it. That is the one of the use case people use. And another thing is that we are having pipelines, and other one is monitoring and controlling. Initially, in the early stages of the build type, right now we are using build type around 3 years right now. In the early stages, we have a good monitoring tool, but now eventually they are even more good monitoring tools. Now it's included test-related results, reporting, and also the large number of, you can see the parallel concurrent kind of a tree views and the waterfall views, and this has a good monitoring view also. Yeah, these are the kind of main key features. As an example, when we think about the GitHub Actions, GitHub Action has a kind of pipeline view. So honestly, I'm a fan of GitHub also. So it's a really nice view. But when we think about this kind of, when we compare it with build type has a nice view with a kind of a waterfall model. Let's think about in one release, if we are releasing 10 to 15 microservices, we need to see what is the state of each microservice. So this is I feel this is a really good service for that. Yeah, these are the benefits based on this ecosystem. We don't need to expose secret and sensitive information, and we have full control in the agent level. As an example, if we are in the night time, if we don't need to maintain any deployment, we can shut down our servers and agents. So everything we have the ability to do with this one. And another thing is we don't have vendor logging. Some of the things when we think about right now, when we think about our company, we don't have much legal, much DevOps team when we compare with the developers. So based on their expertise language, we can write any of script to compatible with the build type. So as an example, I wrote a plugin for build type because I'm a fan of Node.js. I wrote a plugin. It's a really considerable, really big project with Node.js. Honestly, it's performed really well. So, and I wrote some of plugins using Bash also. I think it don't have any kind of a language related logging, so we can use based on our preference language. I think 6 to 7 years before, I wrote some of Jenkins plugins for my previous companies. When we compare with that experience, this is very simpler than that. And I have write a lot of GitHub custom GitHub actions also with the TypeScript and these things. So this is very simpler to maintain. That is the one of good advantage. Yeah. Okay. The one of thing is right now most of the companies move into the monorepo type of code management. So this ecosystem has a good plugins for handling monorepos, because when we go to the microservice architecture, monorepo is the kind of a key area to consider. So, but when we go with the monorepo, handling the multiple deployments is the kind of hardest thing. So, using this for rich ecosystem, we have some well-maintained tools, plugins, and also we can use state management and everything by ourselves based on our requirement. In my example, I'll show you how we can manage the state using AWS SSM. So I have full code also for that one. I'll share with you. And the sequence management as an example. If you need to deploy, if let's think about based on our domain or business, let's think about we need to deploy API, one of our auth service first. The second thing, we need to deploy some kind of a billing service or something. So this kind of a sequence also we can completely manageable with this one. And with the waterfall, that kind of in their graphical illustration, we can easily identify, okay, what is the state and what is the thing I need to continue. Yeah, these are the kind of key advantage when we consider about our experience with the build. Yeah. This is the demo. In the demo, mainly include three main parts. One is the initial setup. I'll show you how I create the GitHub. I'll show you the GitHub repository also. How I configure the GitHub, the build agent, and overview of build type UI and dashboard, and also the monorepo example. Because I create a simple monorepo application with a simple React application and CloudFormation. So we can execute and we can see how it's working. And also another thing, we can deploy small front-end stack related deployment, and also the front-end deployment with the React. So yeah, these are the main things. I will open this code. Yeah, this is the repository created for this demonstration. This is included mainly three main parts. One is the backend, and now I'm not going to show the backend part to make it more simpler. I am showing this front end and the infra part. So in this front end part, this is a completely React application I created with the bolt.new. It's an AI platform because I don't need to spend time to do that one. So yeah, this is the example I created within one prompt. So this is very, very easy to. So this one I hosted. Yeah, this repository included this code base, this is a React application, and this is the infrastructure code, and this is the CloudFormation I created. This CloudFormation included two parts, and one is for S3 bucket for hosting the static content, and the CloudFront to CD. So, okay. Yeah, and there's a backend part. I didn't got much time to check on this one, but however, this has some sample SAM-based AWS Lambda function, but I'm not going to demonstrate that one. I'll show you how we can configure the step-by-step structure, the monorepo. So when we compare this, when we open this one, you can see this is the main entry point for this kind of a build guide project, monorepo one. You can see this is how we can use monorepo. This is kind of a plugins how we can use, and this is kind of a already open source monorepo. We check their code also, the vulnerabilities and everything also before we using this one. This is a really good, well maintained one, and we can use the state management and using the diff, and these are the areas we are managing our services. Let's think that this is the backend part, this is the front end, and this is the infrastructure part. So based on each part, we can have a separate build guide configuration. So in this case, you can see the build guide agent pipeline upload. This one is build guide. It means we are dynamically injecting the next pipeline changes into this pipeline. This is a kind of a dynamically expand the pipeline based on the identified changes. So this plugin identify, okay, which based on the diff, what are the areas it's updated. Based on this update, we are going to buy each services based on the changes. Okay, in the last step, it's for handling, we are storing the state. Okay, if this build is success, okay, this is the state. So this state we are using in the diff level, so to do the comparison. So you can see I am directly at this AWS SS input parameter. I directly use AWS parameter store for storing this one for this project. Okay, I'll show you one of nested one. Yeah, you can see here. Okay, before I go into that one, I'll show you. This is how we can manage the diff part. As an example, we are storing the success git hash. Based on git hash, we are taking the last build, latest build git tag. It's a git hash. So then we are doing the git diff. Then we know what are the file changes. Based on this file changes, this plugin identify. Okay, so this area we need to execute. That's how, this is the way how it's work. But you can check this is a little bit more. But and also you can write, if you are not family to use this kind of plugin, you can write your code also for maintaining this kind of thing. So yeah, okay, I'll go to CloudFormation one. Yeah. When we execute CloudFormation, we need main three things. One is the region, what is the stack name, and related to parameter, so related to the parameter values. So in this case, I added some way we can dynamically select, okay, what is the environment, staging or production, and what is the region. Like that, we can add this kind of our own pop-ups into our pipeline. This is a kind of advantage. As an example, if we need to automate entire part using a build guide, we can follow this one. Let's think about in AWS as a feature called AWS thread sync, that CloudFormation sync. When we go with the CloudFormation sync, they recommend to go with the parameter file. So, but in this kind of case, we can dynamically read our CloudFormation and we can populate this kind of pop-up. Okay, these are the fields you need to put, and then we can add, and we can continue in the same flow. Yeah, this is the kind of advantage. For in our case, some of things I can't expose because of some proprietary license. In our case, we have a custom plugins we develop in-house. So using this one, our entire pipeline, all the microservices, everything can be implemented with these plugins. So this is very helpful. For this one, I wrote some small bash scripts to dynamically generate the pipeline and these things. So you can check this script folder. So this include all the part I wrote there. So and I stack everything step by step. Yeah, this is, you can feel this is kind of too much, but actually this is not a big change, big things. If you think about the front end, you can see the simplicity of this one. Yeah, this is the thing. This is the only script I added there. And go to the front end folder and npm install, npm run with, because this is a React application. Then I am taking the CloudFront ID and S3 bucket. So based on that one, I put the S3, I use the AWS S3 sync, and I'll invalidate for this demo project. So we can run this pipeline if there is a front end chain. Yeah, this is the overall part. Yeah, this is the interesting part of this one. This is the UI view of build type. Build type has we can agent ecosystem. When we compare with the Jenkins has a master and slaves. We can distributely install, spin up the slaves like that. In this one, we can spin up agents as we want. It can be fully scalable. So it's dependent on our requirement. Okay, in this case, I have already spin up one of Docker container in my machine. So I'm using this Docker image, Docker container as my agent. So it's used my machine's resources to build and deploy everything. So normally we are not using our machine, so we can use AWS ECS service or AWS EC2 also. Yeah. So when we registering agents, you can see this is the cluster. So we have already registered one agent. This is agent I run in my local Docker. So local Docker I have already set up AWS SDK, AWS CLI, AWS SAM, and also some of JK and related kind of a code. That's all. So if you need to check on the code level, here I have already add this agent Docker file also. So this is the one of Git repository. So in here you can see this is the command you can execute to run your build kite agent locally. I have already built this Docker image compatible with the AWS services. You can easily spin up and you can connect with the Docker, your build kite pipeline, and you can execute. So in this case, I'm using inside this my local one. I have added a profile. I added a profile for testing purpose. But when we're running in the AWS side, we can use IAM roles to make it more secure. It's based on your requirement. As an example, I think we can add SEM roles and these things also when we're running into different environment. Okay. This is, as I mentioned, this is my repository. So I have two simple code PRs I created. This is for infrastructure. In the infrastructure cloud formation level, I'm not going to do a big change. I'm going to add a simple output because I need to make it faster to execute. As an example, if I do some changes into the CloudFront, it will take some time to run this one. So that's why I add this one. We can do any change here. So I can push this code and we can see it will trigger our pipeline. Okay. You can see. Yeah, this is the pipeline. This is the pipeline upload part. We set up in the pipeline configuration level. I can show you that in the settings level. The rest of the parts we are taking from the code level, and based on the monorepo changes, we are triggering each service. Okay, right now we did some small change into the cloud front. This only need to execute the cloud formation related stuff only. So now you can see it's spin up the cloud formation part. So yeah, this is a kind of a dynamic pop-up we created based on the custom. We can see like what is the environment and what is the region we are going to. So if I continue this one like that, we can do as many of things as we want. As an example, if we need to do adding some drop downs, and any drop down has a kind of limitation, we can add a radio box, multi-select, and everything, most of the things in this pop-up, and we can use to make a more seamless workflow. Okay, yeah, now you can see to make now cloud formation start to execute. So now you can see the output of the, I use AWS SDK to directly show the output in the table view. So you can see the new changes I added in here. Yeah, this is the one, cloud front distribution ID. So like that, we can do the changes based on the changes in the PR level. So we can specifically run the specific service related deployment. That's the kind of advantage we are seeing. When we compare with the GitHub action, if we need to manage this kind of a monorepo, we need to separately write several files for each one. But maintaining wise, we need to adding YML again and again. So in this case, if we have a common bash scripts, we can use them in all places, because we can use the command scripts for running in each dynamic pipeline. This is a kind of a good advantage. The next thing I'll quickly show in the front end part also. So this one, this is the front end change. I did a small change into this title level. Previously it has IP lookup, this is IP address location finder. This title will change. So in this case, this change only goes to the front end part. So this will trigger only the front end part. So all the deployment going through our local container, we use as agent. Yeah, this is the flow. Yeah, this is the you can see now it's trigger the pipeline. After a few times, it will build the VMPAC. We push into the S3. It will do the validation part. So then we can see the changes there. So this is the thing I can show and share with you, because this is a kind of a tool in my class. 10 plus experience. This is a kind of a good tool I experienced. I thought share with you guys. This is not a promotion. This is a kind of sharing. Yeah, if you have anything to ask, please ask.
Sorry, I have a few questions because I'm quite new to BuildKite, but I use it rather quite a lot. So a few questions here. So I noticed in your repo, you are using a plugin to manage monorepo, right? To detect the changes and then trigger pipelines. So I just noticed you are not using the official BuildKite plugin for monorepo. So just want to understand the plugin that you use. How is it different from the official BuildKite monorepo plugin?
That's the first question. Second question is actually a problem that I encountered personally. So I do manage a monorepo as well. So when I do build kite, all this CI stuff, right? What I did was one package, I will have one pipeline per package. So in my pipeline, I don't use build kite upload. I use trigger pipeline. So yeah, I just wanted to know what is your view on triggering pipelines or using build kite upload? Let's say you are managing a monorepo, is it more recommended to use build kite upload or just trigger another pipeline within a monorepo? And then the third question, sorry, is the last question. It's basically when this is the problem that I encounter when I use build kite upload pipeline, is that because they are all in the same pipeline, right? So in the steps, if you have keys that are the same, they will have conflict, right? Like let's say you have a step called block production, and then in your another package B, you also have block production. Basically, they will conflict, right? So like how do you suggest to overcome that problem? So basically three questions. Yeah.
Yes, the first question. When we jump into this build kite, I think 3 years before, that time they don't have a native support for monorepo. There's some plugin developed by Australian team. Still they are maintaining really well. So this is the repo plugin we use. So still we are using that one. Honestly, I don't have a comparison with the native one. What is the performance or improvement, or is there some issues? So sorry for that one. So I don't have statistics or much usage on the official one, because I feel it's when we compare with this one, it's really relatively new. Some of the I feel that the native plugin also inspired from this. So that is the one thing I realized, because this project maintained really well. So that is one of it. Okay, I will go to the second one. Okay, the one of question you asked, when we have keys, we have a kind of a conflict. Yes, that is a kind of a problem. So when we, in our case, we don't face this kind of problem because we have a common plugin we develop. Based on this plugin, we analyze what is the, as much as we can. Okay, we are checking, this is the cloud formation, stack related information. Okay, we are retrieving this information like the existing parameter values and these things. Based on this one, we are making the sequence on the fly, in the code level. We have a custom plugin, but I can't share this plugin. If we can share this one, definitely I think it will be helpful for all people. For still, it has some kind of proprietary, but that's why I will share this one. But in our case, we are not facing. Actually, when we managing, injecting this kind of thing, yes, that's a kind of a problem in build kite. So we need to carefully check it. Okay, these IDs we need to unique. For doing this one, we need to do this kind of nested steps. We thought when we creating this kind of IDs, we are adding a kind of a prefix based on this module. So as an example, when we go into, if we have two services, let's think about that. We have a legacy socket server, we have a new socket server, but both are socket servers. So when we think about this one, if we are using socket server deploy board, so we have problems. We face these problems, and it's make a kind of a weird errors, and that error is, so doing that one, we separate this thing. When we execute this one, dynamically injecting the prefix part of this one. Okay, that's how we can handle the initial. In the plugin system, we don't have that kind of problem right now. That is the one. And when we think about the triggering, yes, we can use the trigger. In the previously, they didn't have that trigger command. So, but trigger is a really nice way. As an example, it's based on the use case we are using. We can use that one. As an example, I give example, we can use the trigger. When we use the dynamic ingestion, I'm not recommending to go with the separated pipeline. So then this agent upload is the perfect way because we can inject something into the existing pipeline. That is the use case for that one. This is a really nice way. Let's think about we have two jobs. Let's think about we have a QA automation. We need to QA automation based on the domains. Let's think about we have a QA automation for kind of a overall API automation. After we run the API automation, then we need to run some kind of another security related automation. So let's think about we need to run based on after we executing the first pipeline, then we need to run the second pipeline. That time it's very easy to one step to triggering that one. And also another thing based on when we use the trigger, we can easily set up that if that conditional values. So that is very helpful for checking the kind of because we know about the build kite has an environment variable, so we can use these variables and we can trigger this one. That is the kind of use case. But for running the external, before we introduce this trigger, we use the build kite APIs because that time they didn't have that kind of a trigger mechanism. So we have API key. We call the next pipeline as the curl code. So that is another mechanism we follow, but now it's very easy. So this is the tool use case we can use the upload and the trigger.
Any more questions? Okay.
So I'm curious about the how's the cache work in build kite, because I think when I look at multiple CI/CD providers, what they are complaining about with it is like a faster cache build and that they have like better caching, because main part of CI/CD is usually installing dependencies. You're doing the same thing. So what possibilities do you have for caching when using build cache? Build kite, sorry.
You are talking about kind of package level one.
Anything essentially like try to avoid having to call external repeatedly, something like that.
I'll give you example because we are mainly our ecosystem goes with the Node.js and JavaScript related stuff. So when we go with the JavaScript, it's using NPM has a ability to we can use NPM. It's completely work with the package level. So when we working with this one, the one of the thing we need to think, this kind of a caching always resides in the agent level. So as an example, if you have a multi-agent one, let's think about agent one, we build once, in the next time it's used cache when we run the same one. But in the agent two, so it doesn't have cache. So this is a kind of a thing, it don't have a kind of a distributed caching. So we can make a distributed caching, but in this theory, it will take some time to cache in all the agent level. All the caching happens in the agent level. So agent level means it can be the EC2 instance or it can be the EC2 service.
I assume your agents is EC2, it's not like running in what do you call that, like an ephemeral environment like the Kubernetes containers where it goes away.
Yes. Yeah. In this case, if you put the EC2 with EBS, the kind of storage, persistent storage, yes, we can manage the cache there. But when we do the previous one, yes, that cache is not much persistent when we compare with that one. Yeah.
Okay, thank you.
Thank you so much, Pasita, for talking about the build kites. Now, so guys, the most important thing. So the most important thing for this event is we need your feedback. Your feedback will help us to organize these events in a more nice and beautiful manner. So I would like you all to scan this QR code on the screen and spare 5 minutes to give us those feedbacks. This will help us to get your perspective of our events, how we are organizing, how we are making things smooth for you guys.
Feedback supposed to be afterwards.
Yeah.
CNC of the not CNC of the open source you shared in the first part, right? That is.
We need to talk about that again.
Okay, yes.
But Kahoot.
Okay, I think we'll tell him make it short. After everything else, we keep the feedback video. Everything.
Honestly, anyone under 30, it's like 50, maybe it's like 3 out of 10 people. So it's the answer overall. And then the reason is like it's really hard for just like talk. What are you talking? Trying to figure like, oh, he's talking to me. Like it's so surprising. It's like really abnormal first review. I don't know, like it's like the adoption probably like
I think all of us are done with the feedback, right? Okay, if you're not, please scan the QR and finish this feedback. We will be starting Kahoot in few seconds.
After Kahoot, we're gonna watch movie.
Yeah. 6, 9, 7. What if someone else can?
Okay guys, make sure your internet works perfectly and make sure you are fast enough to score and to be in the top 3, okay? We'll be giving away some cool Docker swags, whoever will be in the top 3. We have few interesting questions for you guys. These questions are all about these 3 speakers, what they have talked about, and let's just scan and enter into the game. So the pin is 3010007. Okay. Sad guy. You're sad at the first. What happened, bro?
Who is that?
Docker swags. Some cool names. Make sure you use your right name, otherwise we're gonna give away the swags to the sad guy.
Where's the
Docker swag. We want everyone to be happy after this event.
So many of you guys are already sleepy. So this game is just for us to be awake again. So we can finish the game and go back home. So that you guys don't end up in a different house. Docker swags. So let me explain how it works. So the top 3 winners will be getting a Docker swag. Each individually will be getting Docker swags. And this event is kind of sponsored by Docker. So yeah, make sure you guys win. It's very competitive outside here. It's a player game? I don't remove the game.
I think the account he used has a limit of 15 people. So more people, they're giving us like severance. We should watch a movie instead.
Okay guys, we just have a bit technical issue, just give us a few minutes. Sorry for that. Yeah, meanwhile, feel free to recharge you with the drinks over there.
Because like all the keywords you can put in your most jobs, like like your LinkedIn profile, like or, yeah, like or even like just uploading the resume on like jobs. Like I'm Canadian, so we use like a different platform. Your other job, like your second level, using the job tab, you can put like bullshit like Elasticsearch and all the stuff that would give you more views and then other people.
But that looks to me has a
I think that I don't even know what the term DevOps is.
So I guess we can take photo before the leave and then we will continue Kahoot quiz. Or we skip the code quiz. I guess we can skip this time. Who want to skip? Skip the code quiz. We continue? Okay, let's continue. So, just 2 minutes, then we start again. But who is not joining to our, who is not in our WhatsApp group? You guys are not. Okay, so let's go to our WhatsApp group. I'll share the QR code so you can just join.
If I want to turn like something on the bottom, like a
we have like it's just like
we need to make a change on like URL and it's like so many meetings. I guess it's gonna affect anything. Like we need to make sure.
How many of you filled up the feedback form, guys? Feedback form? No? Okay. Whoever wants to join to our WhatsApp group, at the end of the feedback form, there is a QR code. It will invite you to our WhatsApp community.
Like my company's like we can have 0 downtime. Like that whole system is designed to not have downtime. Yeah, it's like so I hate companies like that. Like that's why I do I do like so my job is probably 50% response and like 50% like DevOps or like I work for a Canadian company. Well, yeah, my job is remote, but they don't want me to. have like games yet, they don't know. They're like,
You guys went to our feedback?
But the way it works in Canada is that the contract is the government, and the government is used, so the government pays taxes. So it's like,
okay, so you do it for the rest of the company.
Your tax return is like, before I was in Malaysia for 3 months, and then probably the same term for 5 months. No. I only want to stay in KL. Like I don't want to go to I want something, city, like because like JB and these other cities are probably not as even within KL, like some areas are not Malaysia's look good for hot weather and cheap, affordable for Western. That's me. Before I was in China for 5 months, and I got because of English. Like we talk to you like this, I could not do that in China. It's like and it's my fault because I don't know Chinese. You can't fault. Yeah. But even let's stay connected on IG. I don't use you have WhatsApp? Maybe I can reactivate my Instagram back. Give me your your telephone. Okay, I'm just searching by this.
We are back. Everyone, please sit down. We are back. We are back live online.
Hi guys. So I'm so sorry we cannot take the Kahoot quiz today, but we're gonna take something good. We're gonna take a group photo. So
Group photo time.
please join us here and let's take a group photo together. Okay, so here.
Make sure you guys join us for the next meetup. It's time for 6 swags in the next meetup.
Okay, so next meetup we're gonna have 6 swags.
6 swags next meetup.
Guys, let's join to group photo. Guys, let's go. Let's say group photo.
Photo time, guys, photo time.